Hello, today we're going to do Module 4, Lesson 4. Our objective today is that we're going to relate the side lengths with the number of tiles on a side. Okay, the first thing we need to do is start with our application problem. Pick up my pencil. Mara uses 15 square centimeter tiles to make a rectangle. Ashton uses 9 square centimeter tiles to make a rectangle. Draw what Mara's and Ashton's rectangles might look like. And then we have to figure out whose rectangle has a bigger area and how we know that. So let's start with Mara. She uses a 15 square centimeter tile rectangle. Okay, so something times something equals 15. Well, I know that 3 times 5 equals 15. Could I do 3 groups of 5 with my tiles? Let's do that. And we'll call this one Mara. Okay, so let's do 3 groups of 5. All right, here's my rectangle. Oops, I've already made it wrong. Try again. All right, so 3 groups of 5 is going to be a little longer on top than it is on the bottom. So 3 groups, 1, 3 groups, and there's 5 in each group. 3, 4, it wasn't too bad, was it? Okay, so this is 3 groups of 5. Okay. What is the area of Mara's? What would hers be? Well, 3 times 5 is 15, so hers is 15. We're going to say square centimeters. Okay, we're going to use our units just to make it clear. These are not inches or feet or yards or meters or kilometers. Okay, now let's do Ashton's. Okay, now he has 9. So I can do something times something equals 9. Well, I know that 3 times 3 equals 9. Why don't we do that? So I need 3 groups of 3. So let's see. 1. Okay, there's my 3 groups. 3 in each group. 1, 2, 3. Now, do you see I have extra? This is when I get my eraser handy. And I just erase the extra stuff from my drawing. See how handy that is? Okay. Now, what is the area of Ashton's? Well, 3 times 3 is 9. So his is 9 square centimeters. Okay. Centimeters. Now, so we drew Mara's, we drew Ashton's, we're done with this. Now we need to do B. Whose rectangle has a bigger area and how do I know? Well, we can look at numbers, or we can look at them. Now remember, they all are both square centimeters, so they're the same size as squares, aren't they? It's not like these are inches and these are centimeters. That would be a big difference. Well, what would be obvious? This one clearly has more squares, doesn't it? And when we look at the area, it has a much larger area. So, whose rectangle is larger? Mara's is largest because she has, let me catch up here, she has more square centimeters, doesn't she? Centimeters in her rectangle. Now, did I answer the question? And did I say how I know? I told the answer was that Mara's is the largest, and the how do I know is my F comes after my because. That's like the why. Why does she have more? She has more square centimeters in a rectangle. That's my answer for the why, isn't it? Okay, moving on. Draw a line on your paper. Okay. Now, I would like to make a 3x5 array with tiles or squares. Okay, so I have so 3 groups of 5, so I need to have 5 across. 3 by 5. Okay. 1, 2. Now just like dots, we need to line up our squares when we make our array. Now one thing you'll notice is that we have space in between these because I'm not making a grid. I'm not measuring the area, I am making an array. Now, this is a 3 by 5 or a 3 groups of 5 array. Let me draw another one. You're noticing that this is very different, isn't it? Where's my pencil? Okay, now, just by looking at them, which one has a larger area? This is a 3. This one is a 3 by 5. So 3 groups of 5. I did 3 groups of 5. This one's 3 groups of 5. Which one has a larger area? Well, this one has space. These are overlapped. Can you tell? You can't tell that they have exactly the same area. The area for this is 15 square units, and the area for this is 15 square units. Now there's a lesson to be learned here. This one has spaces in between. This one is all jumbled up together. Why, when we make our arrays and make our tiled pictures, why can they not be overlapped? And why can they not have spaces in between? Why must they be touching? Why? What's the reason? Well, what do you see here? This is 3 groups of 5 in a grid. None of them are overlapping. None of them have space. And what's my area? 15 square units. Okay. Now, you cannot tell that this is the same as this, can you? This is why we make sure that our tiles do not overlap. We want to have the most equal amount or the most equal measurement or use of our area. This doesn't show you area, remember, is, let's do this, area is the space something takes up. Now, does this show the space something takes up? It's got extra space going on. This doesn't show the amount that 15 tiles takes up because they're overlapping. This shows exactly the amount that 15 tiles takes on the table, doesn't it? Okay, now, make sure you understand that. But then that lets us move on to something else. Let's say we have our 3 by 5 array, only this time I'm going to draw it a little bit bigger so you can see it. Try to make it as tidy as I can. Now I have extra, so I erase my extra. Here we go. Now, if I were, now I'm going to say each one of these tiles is 1 square inch. Okay? These are 1 square inch tiles. Okay, so this means that this is 1 inch, that from here to here is 1 inch, and from here to here is 1 inch. From here to here is 1 inch, and so is from here to here. All 1 inch all the way around the square. Now, if that's the case, how can I find out how long each of my sides are? Well, if I take a ruler, I could measure from here to here and find out, right? But I'm wondering, let me get a blue. See if I can get a blue. There's a blue. Okay, I'm wondering if we didn't have a ruler and I knew that these were each 1 square inch, if I could find out how far the distance from here to here is. Well, how about if I just count the sides? Because I know that from here to here is 1 inch, right? That was 1 inch. Well, I bet that's the same here. So this is 1 inch, 1 inch, 1 inch, 1 inch, 1 inch. Well, this would be 1, 2, 3, 4, 5 inches from this side of my rectangle to this side. Well, can we figure the same out from here? Let's see. We know that each one of these is 1 inch, 1 inch, 1 inch. Because each side of a 1 inch square is 1 inch. I didn't even need a ruler for this. I can look and see it 1, 2, 3. So the distance from here to here is 3 inches. So we can use the unit to help us figure out how long each of our sides are. Okay, today's homework. You're going to need to be able to figure out the sides using what you know about inches. Okay? Now, when you write your areas, you are going to write, for instance, that this is 3 times 5. 3 times 5 would tell us our area. It's 15 square inches. Now, the reason why we say it's 15 square inches is because we know that it's this whole square is the measurement. Okay? It's not just one side of it, it's the entire square. So from now on, instead of just writing 15 squares like we did in the past, or 15 inches, we are going to write the area is a number, whatever the number is, square, and then our units. And we're going to put a dash in between to separate it. All right, get back with your homework. I'll see you tomorrow.